Who can tell me the funny word we use that helps us remember the formulas and maybe one of the formulas? Riley? So, and I'm even going to spell it for you, so you don't even have to spell it today. But again, remember we talked about this. You have to know how to spell it, and you have to know how to use it. So what does it tell us? What's one of the formulas? Anything? Sine, S, theta. Thank you for saying theta. By the way, it's not sine equals, it's sine theta. These are the picky things in academic that we worry about, right? Equals opposite, which is the O, over hypotenuse, which is the H. Very nice. Next one, Jaden. I do that every time too. Very good. And the last one, somebody else? Can you give me the last one? Tara? Nice. So there's our lifeblood in this first half of this unit up until the holidays, until we get back in January where things change a little bit. Why? Because this is in right triangles. So these are true in right triangles, but in non-right triangles we have other formulas, which, like I said, we will learn in January. But for now, this is what we need to know. SOHCAHTOA. Everybody happy with that? Okay, get out your calculator. Turn it on. Yesterday, I broke it down for you like this. I look at it as 3 types of equations that you can get in this SOHCAHTOA trig stuff. One of them is x on top. You end up multiplying. One of them is x on bottom. Swap places, and you end up dividing. Right? It's algebra, right? You're just doing some algebra. So that's one way of thinking about it, though. And if you did the practice, you probably know exactly what I'm talking about. Like, yes, I remember. X on top, x on bottom. This is the third kind. It's not an x, it's a theta. Remember we said we use theta for angles? Theta, x is the angle. X, our unknown, our thing we're looking for, is the angle. When you're looking for an angle, there's something you have to remember. If you don't remember it, you just won't be able to do it. Okay? So that's what we're about to learn right now. Uh-oh, if this works, which it didn't. Oh. There we go. Okay. See if I get less glare with the lights off. Not really. Okay. So, shift tan. I'm just going to move this over so I can see the question. Bracket. That's what you need to remember. Some people, their calculators open a bracket for them. Otherwise, you have to put a bracket in. You have to. If you don't do it, you'll get the wrong answer. Shift tan. And the shift part, or second function on some people's calculators, is called second F. Shift tan, because when you hit tan of an angle, if you put an angle in, that's what we did on Friday, you're finding the tangent of that angle. But we're looking for the angle, so we have to do the opposite, which is shift tan. Okay? And then it's easy, just 3 divided by 5. There's nothing to this. That's it. That's like almost all the learning we're going to do today. Everything else is same old, same old. So it's really easy. But you have to remember shift, tan, bracket. And how many people got 31 degrees? As a standard, we round to the nearest degree. Often in questions it will tell you, but even if it didn't, in fact, on the test, you'll notice it'll say round all side lengths to 1 decimal place, round to the nearest degree unless otherwise instructed. And that's a standard, round to the nearest degree. That's exactly right. There's no steps involved. There's no rearranging. It's already done. However, notice that I didn't write, like some people might just do this. They might just write equals 31 degrees without that part. Shh, guys, listen. That's wrong, because what you're saying is tan theta equals that, which is not true. Theta equals, so you have to, some people do mess that up, and you have to remember, get rid of that, you have to remember to write theta equals, that's what we're trying to find. So that's the only rearrangement that there would possibly be. It means inverse. It's a convention that's used here and there in mathematics That means you're doing the inverse operation. It's a little bit weird because it also looks like to the exponent -1, which is a reciprocal, which is not what this is. And there are reciprocals of sine, cosine, and tangent that are something else that you learn about in grade 11. So it's a weird notation. And in fact, I've even seen people like in mathematics say like, we should change this. You sometimes see it called arc tan, arc sine, arc cos. But it just means we're undoing the tangent in this case. Does anybody have a one-step calculator? It was like they're reading my mind. That was incredible. He was handing it to me before we started. Okay, how would you do it on a calculator like this? 3 divided by 5 equals shift tan. Bam, 31 degrees. Easy enough, right? Good stuff. Try the next one. Who's got an answer? Mahmoud?
77 degrees.
Nice. 77.16, but round to the nearest degree is 77. And the last one, it's not different if you're using tan or cos or sine, right? Tangent, cosine, sine. It's not different. You just hit the different button. The math is the same. Okay, one more. Yep. Yeah, 53 degrees. Very good. Everybody got 53? So that's how you use your calculator. There's 2 more questions here I want you to try. I don't want you to say anything. I want you to try the first one, see what you get, keep it to yourself, and then try the second one and see what you get and think about it. Go. You don't have to write anything down. Just try it on your calculator. What happened? Error. How many people got error for the first one? Nobody wants to admit it, right? Or a couple of you did, but some people are like, I'm doing it wrong. I'm not going to say anything. No, you did it right. You got an error for the first one. Did you get an error for the second one? No? Good. I hope not. Why? Somebody explain that? Liam? What, very nicely put. But why? Because you're exactly right. Why? There's more to sine, cosine, and tangent than we will learn in grade 10. You'll learn a lot more about it in grade 11, and then obviously you can keep going. But our view of this stuff is with triangles. So in the context of triangles, why can't I? In other words, a number bigger than 1, right? Why not? You know why? Not sure. Okay, very good. That's okay. Jaden, what do you think? Hypotenuse, which is going to be on the bottom, has to be bigger, which means my fraction is going to be like a decimal smaller than 1. Very nice. Good job. Does that make sense? It's not necessarily something you need to know, but making that connection will probably help you. So sine of 5/3 didn't work because that's opposite of 5, 3 hypotenuse. Try to draw a triangle like that. Show it to me. We'll make a lot of money. We'll write a paper. Okay? What? There's a lot of money in math papers, by the way. Just so you know. Why did tan work? Why did tan work if sine didn't work? Anybody else? Rachel? Riley? Yeah, it's opposite and adjacent for tangent, so either of them can be bigger. Exactly. What? Yeah. Hi. Yes. Absolutely. Yeah, thanks. Okay, so that's that. So very good. Riley said opposite and adjacent, either can be bigger. So the nice thing here is if you make a mistake and put them upside down for sign, your calculator is going to catch that mistake. It's going to give you an error. You're going to be like, wait, what happened? Oh, I got them backwards. But it won't do that for tan, so you have to be careful. The other thing that sometimes happens, and not every calculator will do this, because some of them put a bracket automatically, but if I go shift sign 3 divided by 5 without brackets, it's going to give me a math error, because it's trying to do shift sign of the 3 first. Whoops. And like it's a bedmass mistake. It's trying to do shift sign of 3, like 3 over 1, which can't be true, and then divide that whole thing by 5 if you don't put brackets. So that's why you need to open a bracket and put the dividing thing inside. This is not a question you'll get. I'll never give you a question like this. It was just about thinking. So for your note, if you want, you can write error. And that one gives you whatever it gives you. I think we've managed that, so don't worry about it. All right. Let's see what these questions actually look like. Let's do a few. It's exactly the same otherwise as what we were doing yesterday. There's nothing different here. You don't have to write down the steps. They're the same as before. You already wrote them down. So example 2, solve for each indicated angle. Draw the triangle. Label it like mine. Everybody ready? Notice that the steps, as I said, are identical. So what do we do first? Label the sides. There's hypotenuse. Somebody help me with opposite, because on Friday we were given an angle and I went opposite from the angle. So what do I do here, Liam? Yeah, 13. Why is it 13? Yeah, it's opposite. Listen carefully, from the angle we're looking for, right? In this case, we're looking for theta, so I go opposite from it. And then the last one is adjacent. And then I can circle those two if I want and do it the same way. You can sit here or back there, wherever you want. So I'm going to pick my formula, pick which ratio I'm going to use. In this case, I'll use sine. Opposite, which is 13, over hypotenuse, which is 18. And my calculator does this part. Notice these are only 3 steps. Fridays would have been 4 because you have to rearrange. But the 3 steps are write the formula, show your substitution, rearrange if you have to, and then your answer. Always worth 3 marks, whether it's one kind or the other, worth 3 marks, but you got to show all your work. Shift, sign, bracket. I got 46 degrees. Did you get 46 degrees? Awesome. Any questions? Yep. Not for this. You wouldn't be able to. The only thing is, when I went to high school, I can't believe that this is even true. Like, I'm not that old, but like, when I went to high school, the back of the textbook had about 10 pages. I should find an example of it. Had about 10 pages of what are called trig tables. And so calculators that could do sine, cosine, and tangent weren't common enough. So what they did for it must have been every angle from like 0 to 360. They had the sine, the cosine, and the tangent of that written out into 4 decimal places. And so every time you do it, you'd have to flip to the back and scan through it and find it, and find the ratio, find the number, and use that. It was a lot harder, actually. And you probably had to understand it a lot more than you guys do now. And something like, you'd have to understand where to put that number and what to do with it. It's probably a lot harder. So with the modern miracle of advanced calculators. Trig's a little bit easier. So yeah, nobody would ever ask you. Maybe there's like a teacher somewhere who's like, I like old school trig tables, and they give their students all trig tables, and then don't let them use calculators. But otherwise, you can't. Like, you can't do this by hand. Not like it's entirely impossible, but it would take a long time, and you'd have to go to university to learn how to do it. You have to learn all this other stuff about series and sequences and stuff before you can even do it. Okay, go ahead and do this one on your own. At least get it started and set up. What's the first step? Label the sides. Why do you label the sides? So you know which of those three ratios you're using. You got to decide, is it sine, is it cosine, is it tangent? That's what I got. Is that what you got? So I'm going to use Ziggy? Oh. I thought maybe you would have caught on by now. That's okay. So which one am I using? SOHCAHTOA. Liam? Yeah. Oops. So write the formula, tan theta equals opposite over adjacent. It's funny sometimes the mistakes we make. I've seen people do all this great work, label the sides correctly, even circle the labels, write the correct equation, and then somehow flip, and for adjacent, they put the 11.4. Like, they just write it wrong somehow. Like, why does our brain do that? Transferring numbers from one place to another, I don't know why. But even though they've got it labeled, and they've got adjacent right beside 5.1, and then they put it in the wrong place. So just be careful, I guess. What's the answer to this one? 2? That doesn't sound right to me. What do you think?
0.447.
That doesn't sound right either. I think there's something missing with the calculator stuff. Is it correct? 65.1 or 65 degrees, that sounds about right. In fact, I could know for a fact that it's not 2. Because 11.4 is bigger than 5.1, so the angle is going to have to be bigger as well. Once this clicks for you and you understand that, I can use a little bit of logic to realize we can't always do that, but if you get a really small angle or something like that, sometimes you can really tell. So on your calculator, what you should put, let me see, what you should put, okay, yeah, is shift tan bracket, and then 11.4 divided by 5.1. Hit equals, and it should give you the answer. That would be 66.
I got a syntax error.
You probably didn't put I don't know what you did. Try it again. Shift tan.
I got shift 10.
Oh, why do you have a 0 in there? Shift tan bracket, open bracket.
Like that.
Yep. 11.4 divided by 5.1. Yeah, okay, so 66. That's okay.
Yeah, I got 65.
Good, 66.
That is weird. I don't like that.
One more thing, if you weren't here on Friday, you didn't learn how to do, it's a convention that we need to know what it is to help us draw and label this triangle. So go ahead and draw a triangle. And I can label my right angle with the right angle symbol. Now there's one, is everybody okay? Is everybody with me? There's one part of this that I could easily label? Does anybody want to help me out? Where do I put the ABC? Somebody get us started, Tara. Which is what? Yeah, so capital C, a big C, is my 90. Good. What else can I do? Yeah, good. Right, so if you weren't here on Friday, this is the convention. Across from big C is little c. Always, always, always. I don't know for sure, but I'm kind of guessing that 58 is the shorter side. So I'm going to put A over there, which puts big A here. And then I'm assuming that the other one's supposed to be B. It doesn't really say, but you can call it whatever you want, I guess, but we'll go with B. Some people think because of Pythagorean theorem, C is always the hypotenuse. That's not true. That can get very confusing. But if I label the triangle with A as the hypotenuse, then that's the way it works, right? Alan? Yeah. I just chose. There was nothing that said it had to be. I think it's going to be the smaller of the two sides, so I put it on the smaller side, but I don't know that, and I could be wrong. We'll do the math and find out. What do we want to find first? We want to find A first or B first? Let's find A. Let's just do it alphabetically. So here's what I'm going to do. I'm going to give myself a little title, something we do tomorrow. This will be helpful. So whenever I'm finding two things, like in all the other examples, I was only finding one angle per question. Now I'm finding two. I'm going to give myself a little title, label what I'm doing. If I'm using A, here's the hypotenuse, and here's opposite. Those are the two that I have. So I'm using sine. Does everybody agree? Sine theta is opposite over hypotenuse. So sine of A, right? Because A is what we're looking for. That also helps for clarity. Okay, go ahead. Finish that one off. Yeah, see, I was wrong. You should get 45.7. Very close to 45, but 46 rounds up. So right there, it told me my diagram's not very well drawn to scale, but that's okay. Are we okay with that? Okay, now I just want you to put your pencil down and think for a second. Something tricky happens here when I find B. Can anybody describe what happens when I look for B? There's two ways to do it. There's an easy way. We'll talk about that in a minute. I'm going to do it the hard way because we're going to learn something important from it. So we're going to use trig. We're going to use SOHCAHTOA to find it. So what happens when I find A? Or sorry, when I'm looking for B, is it still opposite and hypotenuse? And then you think no? Can you explain that?
The small d would then be opposite.
Okay, so this is what you have to watch. This is what can be confusing. That is no longer opposite. This is, here, I'll do this in blue. It'll match nicely. This is now my opposite, and this is adjacent. Because I changed the angle. When I was using this angle, it was opposite. When I'm using the blue angle up here, B, it's adjacent. So for B, it's going to be cos theta. Same numbers, but a different ratio. Instead of sine, I'm using cos. So cosine of B is 58 over 81, and that's interesting. I still get 58 over 81. And what do I get for B? Somebody help me out with that? Tony? 44. Who can tell me the other way I could have got it? So this is probably how you would do it. You would go B equals 180 minus 90 minus 46, which is 44. You could use trig if you want, but if you found two angles and you have to find the third, that's the easiest. That's full marks. That's what I would expect. That's a 1 mark part. You still have to show that step, yes. Because if you just write equals 44, I'm like, how did you get that? I want to know how you did it. Did you use trig? Did you guess? Did you cheat and copy off the person beside you? Okay, questions? Everybody good? All right, we got one more part here. Whoop, whoop, whoop. Uh-oh. Hold on. It's missing. Okay. Couple of terms. We're going to do a little bit of applications today. These are super easy compared to the ones you've done so far. So the first part of this, you can get this set up, like start copying this down, and I'm just going to write always always start from horizontal. I hope by now we know what a horizontal line is. Does everybody know what a horizontal line is? I really hope that you do, compared to a vertical line. What is a horizontal line? Well, I've drawn one there. The horizon, right, flat. So I need everybody to put down their pencils. This is going to be an interactive demonstration. You ready? Put your pencil down. Take your arm and make it horizontal in front of you like this. Come on, everybody. Let's go. Let's go. Let's go. There's always one, and it's always Dylan. Okay. What does the word elevate mean? It means to go up. Very good. There you go. There's your angle of elevation. Look at the angle that my arm is drawing. Angle of elevation. Start from a horizontal and go up, like you're waving at somebody. Angle of elevation is like you're waving. How's that sound? So I start here and I go up. Everybody get that? Seems obvious. Angle of elevation is usually easy. People don't have a problem with it. Think about starting on a horizontal line and going up. What angle are you tracing? The angle on your page has to look like that. Okay. Angle of depression also starts on a horizontal. What does depress mean?
Sad.
Yeah, like sad, but like down. Like if you depress a button, you're pushing the button.
It depressed the button.
That's mean to the button?
When I finished the noodles your mom gave
Yeah,
me yesterday, I was kind of depressed.
The button's depressed. It's not feeling very good about its life. Start on a horizontal and go down.
See, that's what I was talking about.
Does anybody in here have a younger sibling?
Smack them.
Imagine you're hitting them.
I've no other siblings.
Get out of my room.
And watch me smack that. Oh, smack that.
Okay. Listen carefully. Angle of elevation is easy. Nobody ever gets that wrong. I'll never say never, but almost nobody ever gets that wrong. Angle of depression, half the people get it wrong every time. I'll show you why. I'll show you the famous mistake when we do this first example. I just want you to watch it. I don't want you to write down this example. You can look at it later. Here's what people do. An airplane is approaching the runway. It's currently 800 meters in the air. Okay? And it's approaching the runway at an angle of depression of 9 degrees. So that would make and there we go, 9 degrees. That's what people do. because the angle of depression is up in the air, and so that's where it goes in my triangle. What did I do wrong? Alan?
And it's supposed to be on the other side because that's like bigger and that's over there.
Yeah, you're right. That's one part of it. But in terms of our definition, what did I do wrong?
Did you have to flip the triangle?
That's one thing we can do. Good, Tara? It's supposed to start on a horizontal, and this one doesn't. So here's two things you can do. Remember, you're just watching right now. You can do this and put it where it belongs. And then this is parallel to this. So how can I put that angle in my triangle? But why? Why can I do that? It's a Z law. Z, right? So it goes here. Or like Dylan said earlier, what if you drew your triangle upside down? So this would be my 800, and this would be my X. You need your X in there as well. What are you finding? The horizontal distance to the runway. Either of those diagrams would be good, but I would like to see you have the angle of depression drawn in properly. So either put the dotted line and put it here and put it there, or just give me that one. Does that make sense? A lot of you are going to be like, well, I'm just going to do this, but I'm going to put it there. I'd rather you see, like if it says angle of depression in the question, show me that. Okay? It's a nice little addition. Okay, we're not even going to solve it. It's too easy. Everybody got that? Any questions? Okay, the last one, I'll do this one really quickly, I guess. All it says is, most questions in this, are going to be really straightforward. I'm not even trying to, I'm not trying to trick you or anything like that. But notice how this says Ned is standing over here, and he's measuring the height of his building. Okay, and he uses a clinometer, which just, you hold it up to your eye, and it measures an angle from the horizontal, okay? So here's the horizontal, and here's the angle that he would measure. His building is 135 feet tall, but he is about half of that. In my diagram that's drawn really nicely to scale, is 6 feet. So what is that? So once in a while, you have to kind of think a little bit, and so that makes this 129 from here to here, and that's the triangle that you would use. And in this case, you're finding the angle of elevation from his eye line to the top of the building. But you have to take that 6 feet into account. Not that often do you get questions like that, but they pop up here and there. Any questions?